Hello everyone, in this video I'm going to give a tutorial on dataset management with Voxel 51. Voxel 51 is a powerful tool that is designed for computer vision dataset management, and it has lots of capabilities which can handle different computer vision tasks such as classification, object detection, and instance segmentation. And besides that, it also has a dataset zoo where we can download publicly available datasets easily, as well as a model zoo where we can leverage some of the published models and apply that to our datasets. So let's get started. First, if you need to install FiftyOne, so you can use this pip command. Since I've already installed that, I will skip over that one. And next we need to import these packages. So FiftyOne usually is the common convention that we import it as FiftyOne and then use FO for short. And then we also need to import FiftyOne.zoo as FOZ. So let's run this cell. So first let's list all the available datasets in FiftyOne zoo. So to do that, we use FOZ for FiftyOne.zoo dot list zoo datasets. So if we run that, it will give us a long list of available datasets, and let's see how many datasets there are currently. So currently there are 33 datasets available, and maybe one more thing to do. So let's go back and list that. And another useful function is pprint for pretty print. So let's do this one. And so yeah, here are all the list of all the available datasets. So next, let's look at, for example, this CIFAR 10. So in order to load the CIFAR 10 dataset, we say ds equals foz dot load zoo dataset. So we need to provide the name, that is CIFAR 10, and then the splits. So we say which split, train or test. So in this case, let's say both train and test. And then another function that we can use, another attribute that we can specify whether it needs to be persistent or not. So let's just say persistent equals false. And finally, how many samples? Usually you don't need to provide this, but for us, in order to make it faster, we just want to download 50 samples from this dataset. So let's do this, and then after we download the dataset, we want to print the status of this dataset, the stats of this dataset. So let's run this. So it downloads 50 samples from the train and 50 samples from the test. And then after that, it prints this dictionary, that is this ds.stats. So total it has 100 samples, and these are the number of bytes. Now let's look at some of the samples from this dataset. So we can get the first and last sample easily with this command ds.first. That will give us the first sample, and we can get the last sample similarly as ds.last. Right? And then we can look at the first sample. All right. So each sample has a unique ID, and also this media type specifies the type of that data. So this is an image, and the path to that image. So after running this load zoo dataset, it downloads the CIFAR dataset with how many specified this number of with this specified number of samples, and after download, it is stored in this path. And this particular sample has the tag of train, so that means this is part of the training set. And finally, it has this ground truth label, which the type of this ground truth label is from classification. So that is good for a classification task. And the label of this is frog. As you can see, it also supports these default keys, confidence, and logits. But since this is ground truth, we don't have that. But if we specify a prediction, we also specify from the same class, and we specify, we can give confidence for that prediction and the logits. But this is just ground truth, so we don't have those. Next, so how can we get the file path? So to get the file path, we can easily use either this sample.file path. First sample.file path. First sample.file path. Or I prefer to use this bracket notation, because even in pandas, like, it's better to use these bracket notations, because maybe like the key that we are using, maybe this it has a reserved attribute or method. So yeah, this way we can get the file path. And similar to pandas, we can it also supports the head method, so let's use that one as well. So we can say ds.head. It will return a list of the first 10 samples. Right. So if I print the type of this, you can see that this is in fact a list. Yeah. Next, let's take a slice of that data set. And basically, anytime we do sorting or slicing or searching through a data set, what it returns, it will be a data set view. So to do that, we can just say view equals ds.take, and we can say how many samples we want to take. So for example, let's say we want to take 20 samples from here. And then if we print the view, so this view has 20 samples, and these are the information about this view. Now let's visualize this data set. So for visualization, obviously, like Voxel 51 provides an app that can easily visualize. But for now, just to understand the structure of this data set and samples, so we want to loop through the data set, take 64 samples, and then read the image from the file path that corresponds to that sample, and then put that in a matplotlib figure. So to do that, I have this code that basically get the samples from this view of ds.take 64, and then it assigns the row and column based on this index I, and then it reads the image with pil, pillow.image. And after that, it will call IAmShow to basically show that image in the matplotlib. And after that, I have this for loop comprehension that set the axis of each axis in the plot to off. So let's run this. Right. And after running that, yeah, this will provide this plot that contains 8 by 8 images from that data set. Another way to visualize the data is using the FiftyOne app, and that's very simple. We can just create a session like this. Session equals fo.launch app, and then we need to provide either a view or a data set. So let's just use the data set itself. And note that here I'm running this in a notebook, in a Jupyter notebook. So just like this, it will launch the app. But if you're running this as a standalone script, then you need to also provide this line, so uncomment this line. That way it will wait for the execution of the app until you close the app. So now let's run this. So now the app is running here in Visual Studio Code. If you are running it as a standalone script, then you can open the app in a browser. And now, as you can see, these are some samples from the dataset. So you can click on each one, and you can see basically the label of that sample. Right. So next. Let's reload this app with a different view that the labels are sorted. So to do that, we say that we create a new view. We say view equals. We say ds dot. First, we need to make sure that the labels exist. Ds dot exists ground truth dot label, and then we sort the labels by or sort the samples by this label, ground truth dot label. So what we do here, at first we are making sure that we are filtering the samples that have the ground truth label. And then after that, we sort the samples by that label. And we can also specify the direction of sorting. So we can say reverse equals true. So we create the view, and now we need to relaunch the app with this new view. So that's also very easy. We say we already have the session, right? So we created the session here. So now we change the view of that session. We say session that view equals this new view. So if I run this, it will create a new view where the samples are sorted by their labels. So you can see all the trucks are here. Then after that, the class of the samples for sheep, and after that horse, and so on. So now let's look at the existing datasets or the datasets that we have previously created. So to do that, first we can use a list of all the datasets that are available on this machine. So here we only have like one dataset that we just created, Cypher 10 train test 50. This name is given when we loaded that dataset from Zoo. So it adds this tag for the splits, train and test, and then the number of samples, 50. As we go on, like we may create multiple datasets, and then this list will expand. But now, for any dataset that is listed here, we can easily load that using this command fo.load dataset, and then the name of that dataset. So that is this. So we can just copy this and put that here. And then we can print the stats of the datasets. Right. So that's the same dataset. And if you want to delete a dataset, that's also very easy. We say ds.delete, but make sure that you don't lose any information, any data. But after running this, then let's check the list of datasets. Right, so now the list is empty because we deleted the only dataset that existed. So in the next section, we are going to create a dataset from our local files. So I have created a small set of images and their annotations. So there are 13 images in JPEG format and their annotations in JSON, and they are located in this data folder. So this is available in the GitHub, so I will put the link in the descriptions of this video. Now we need to create a data set for classification, a data set for object detection, and a data set for instance segmentation. So first, starting with the classification data set, we create a data set with this name, my classification data set. And to create a new data set, we use this fo.dataset with capital D. So this will create a data set. But if this name already exists, it will give an error. But for now, it's fine because I don't have this data set. And now I have created a data set that has 0 number of samples. The next time, so now since this data set exists, I cannot run this command again. If I need to load that data set, I need to just use fo.load dataset. So we can do that as well, and you can see it will load the same data set that has 0 samples. Next, we need to create new samples from this folder structure that I showed you, and we add that to the dataset. So for creating a new sample, FiftyOne has this fo.sample that we need to just provide the file path for that sample. So here I have like this path for this image pic01.jpg, and by running this, it will create a new sample for us. So here is the information about the sample. So the ID is none because it's not added it's not yet added to the dataset. But once it is added, then the ID will be specified by the dataset. And then here is the file path. And currently it doesn't have any tags, but we can also add some tags if we want. So adding some tags is very simple. We can just say sample tags dot append. So let's say, for example, train, and then we can reprint the sample. So now this sample is assigned to the training set. Next, we need to add some labels to this sample, right? So the labels, the annotations are provided in this folder data/annotations, and they are in JSON format. So let's load one of these annotation files. Right. So this annotation file has basically the file name, pic01.jpg, the width and height of the image, and then it has a list of annotations. This list provides two things. First, what is the label of that image? So this particular image is from the class of birds. And then the next one is a polygon. So this is a shapely polygon that has like coordinates for the polygon around the bird in the image. There are 4 different types of labels in FiftyOne that are supported in FiftyOne. One is classification, so we can do multi-label as well as multi-class and as well as multi-label. And then we can also do object detection, polylines, and key points. So for now, let's create a classification label. So to do that, we provide fo.classification, and then we need to provide the label for this type of classification. So the label is provided from this JSON or this dictionary that we loaded, right? So the annote, and then we have the results. And now this one is a list, so I will provide the first item in the list, And then once I get to this list, then we have this dictionary. So then I provide the key that is label. So in this case, we only care about classification, so we are completely ignoring this polygon. And if I run this, so we get this object of classification. It has an ID and the label, and this confidence and logits are none because we don't have those values. This is ground truth. But if we have a prediction, it will be very similar. We create an object of classification, and then we provide, we have the option of providing the confidence or logits as well. So this, when you provide logits for predictions, these logits will be used for performance evaluation. So now, since some samples may have like multiple labels, right? So that is good for multi-label classification. So how do we provide multiple labels? FO.classification only accepts one label, right? So in this case, this is just bird. But if you have multiple labels for one sample, we create a wrapper SFO.classifications, plural, and then inside this we can have a list of all the single class classification objects. So for example, we can copy this. So here we have classifications, and then inside that we have this list of, even though it has only one, but yeah, here this is how it is done. Okay, so this error is means that we need to provide the argument. So that I think it is classifications, right? So yeah, so now we have a list of these labels. So we have classifications, and inside that we have this list of single labels. Now that we have created this multi-label classification, let's assign this label to our sample. So we say sample bracket ground truth equals, we can copy this. And once again, if you have just a multi-class classification, we just need to provide a single class like this. So let's actually do that. So this is what we do for multi-class. But for multi-label, we need to do this way. Sample ground truth equals this, right? So let's just use one of them. So I will comment this other one. For multi-label, we use this one. And then let's check the label that we have just assigned. So if I copy this, so now this sample has this ground truth label. All right. Now let's add samples to the data set that we have created here. So we have created our data set with this name, my classification data set, and now we want to add samples. So to do that, we have basically first we have these two directories for images and annotations, and we need to loop through the images. So for file name in we use the OS package, os.list there, and the images directory. And we just need, we can also put a condition here to make sure that we are only dealing with JPEG files. So we say if not file name that ends with .jpg, then skip this this file. And then we set the image path equals os.path.join images directory and that file name. And then also the annotation path is os.path.join annotes there, and then file name, but we need to replace the extension JPEG to .json. So now we create a new sample, we call it fo.sample with our with file path equals img path. And then we need to assign the label. So we say sample ground truth equals so since some of our samples have multiple labels, we use this classifications, and then we provide this argument classifications equals fo.classification label equals. So here we need to have a for loop. We have this list here, so we use list comprehension. We say label equals res of label for res in annote. Yeah, I haven't loaded the annote yet. So we say annote equals json.load. We open that annotation file. Annote path with read in text format. So here we are reading that JSON file, right, and then we loop through all the results. So remember that this annotation has this format. So let's look at that again. So it's a dictionary, and inside the dictionary we have results, which is a list of another nested dictionary. So when we say, where were we here? Annote results. So this is a list. We loop through that list for res in annote results, and then a label is res of label or res bracket label. So yeah, we are creating a list of this classification label, and then we assign that to these classifications. So next we say that so we have created our sample, we have assigned its label or labels, and then we add that sample to the dataset. We say ds.add sample, this sample. Right, so after we loop through this all the images in this directory, then we add these samples, we create the samples and add them to the dataset. So now at the end we want to print the stats of the dataset. So we started initially with 0 samples, and then at the end let's see how many samples would exist. So after running this, yeah, we have a total of 13 samples. Now that we have loaded or added the samples to the dataset, let's visualize the samples in this dataset. So note that we previously created a session and launched the app. Now we can reuse that session and change its dataset. So previously we saw that we could change the view of a session and it would relaunch the app. Now instead of view, we change the dataset of the session. So we say session.dataset equals ds. So by running this, we see these 13 different samples here, and all their labels are also displayed. So this image has two labels, cat and dog, whereas this one has only one, just dog. So yeah, this is good for multi-label classification. For multi-class classification, we need to filter out the images that have more than one label. Now in the next section, we want to build a data set for object detection with bounding boxes. So we use the same data set with this image directory and the annotation directory, and now we want to, in this section, we want to try creating a new data set in a different way. So previously, if you remember, if you go up here, we created the data set by this data set class right here. So this would create a new data set with 0 samples, and then we had the loop to add samples one by one. But instead of doing that, we want to load the dataset directly from an image directory. So FiftyOne provides this function called fo.dataset.from images directory, and we need to provide the directory of the images and as well as a name. So we call this my detection dataset. And now let's look at this, the stats of this dataset. Right. So now we created a new dataset with this name, and this dataset has 13 samples already. So it has all the image information, but it doesn't have the annotations. So next we need to add the annotations. If you want to see that, so let's look at the first sample. So as you can see, it only has the image path, but it doesn't have any annotations yet. So next we need to add the annotations. So to add the annotations, remember that when we loaded that JSON file, it has a polygon shape from Shapely. To read and process that polygon shape, we need to import WKT or well-known text to process the polygons. So now we loop through the data set. We say for sample in ds. First we get the file name of that sample. So we say sample.file path, and we just need the base name. So let's use the OS package os.path.base name, and then we can build the annotation path from this file name. So we say annotation path equals os.path.join the annotations directory and file name, but we replace the extension with JSON. And in the next step, we load the JSON file. So we say annote equals json.load. We open the file, annotation path in read mode, and then we create an empty list of for detections, and we loop through all the results section of this dictionary. So this is a dictionary. The annote is a dictionary. So for res in annote results, we create the polygons, because right now if you look at so let's actually do that. Let's load one of these annotation path and look at the results section of that. So we provide an annotation path from data annotations, and we say, for example, pick let's say pick10.json, and let's look at this annote, right? So this pick 10 has this is the image width and height, and it has two labels. One is a cat with this polygon around the cat, and one is a dog with this polygon. But you can see that this is actually a text or a string, right? So if I say annote results and then I specify polygon, this is a list, so I need to provide, for example, 0 and then polygon. This is a text. If I print the type of this, this is str, right? A string. So with WKT we can process this string and convert that to a real polygon. Let's actually do that. So we say I need to bring this here. So wkt.load s for loading a string. So this will create a polygon. So if I run this, this is a shape of a cat, or the first one is a cat, right? It's upside down, but that's fine. It aligns well with the image, but when we visualize it this way, because the coordinates of an image is upside down, so that's why it is shown here this way. But anyway, so now we loop through all the results, and then we create a polygon using this wkt.load s, load string res polygon. So this will be the polygon itself. We also need the label, but that's fine, we have the label, we can get the label later. But for object detection, so this is the polygon, right? For object detection we need the bounding box, but using this Shapely, it's very easy to generate bounding boxes. So once we have this polygon, we can say xy, so the or x1 y1 x2 y2 equals polygon that bounds, right? But one thing to note is that FiftyOne expects the bounding box in XYWH format. So we need to update this bounding box when we create that. So we say let's create a detection. We say fo.detection we need to provide the label. The label comes from res label, so that's easy, that's a string, so that's fine. And then we also need to provide the bounding box. But as I said, the bounding box needs to be in format of XYWH format, right? So for XYWH we use x1, y1, and then we need the width and height of the bounding box. So we say x2 minus x1 and y2 minus y1. Right. So we create a detection, and technically an image can have 0 or more, right? It could be 1, 2, or many more bounding boxes, or many more objects, right? So we need to append this detection det to detections list. So we say detections.append det. Then after we finish this for loop for all the results in the dictionary, then we say sample ground truth equals. Now we create a new class or new object of type of class detections, and we say detections equals detections. Right. So doing this will add this label or annotations to that sample. However, since we created a data set with samples first, we are not adding the sample to the data set here, right? We are just adding the annotations to that sample. So in this case, we need to call the save method on the sample so that these annotations will also be saved in the data set. So we say sample.save. So doing this, it will save the annotations in the data set. So let's run this. And now let's visualize these bounding boxes. So we say session.dataset equals this new ds. So now, as you can see, there is a bounding box around each object, each cat, dog, or bird. And you can also change, if you expand this section here, you can select the dogs, you can select the cats, all the images that have cats, or the images that have bird. And it also provides a way to change the color of the bounding boxes. So for example, we can let's use this color. Right, so now the color of the bounding boxes have changed. Now in the next section, we want to create a data set for instance segmentation with polygons, or in FiftyOne they use Polylines. So we use the same image directory and annotation directory as before, but let's create a data set. So I will just copy this command here. So this time we call it my segmentation data set, right? And we provide the image directory directly, so it will create a data set, and it has 13 samples already. And now we need to loop through the samples and add annotations to each sample. So let's do that. So we say for sample in ds. Similar to before, we get the file name for the image and the annotation path like this, and then we read the JSON file. We say json.load by opening the annotation path and in RT mode. And then we create an empty list of polylines, and now we loop through all the res in annote, the result section of annote. So similar to before, we create a polygon using wkt load string res polygon, and then we create a polyline. Let's call it just poly equals fo.51.polyline. So we need to provide a label for this. So the label comes from res label, comma. Now we need to provide the points, which is a nested list of coordinates. So we create a list here So it will be a list, and then inside that will be another list. Then we say polygon dot exterior dot chords. So why this is a nested list? So let's so it is a list of then x and y coordinate. So the reason for this is that, you know, sometimes one object, the polygons for one object may be disjoint. So that's why we have two lists here, like nested list. So each internal list is for one polygon, one complete polygon. But then since we may have like disjoint polygons, we have another list. In this data set, actually, each object is identified with just one polygon, but still we have to provide a nested list anyway. And then we also provide whether this polylines is closed or not. So we say closed equals true. After that, we add or append these polylines to polyline to polylines. So we say polylines dot append poly. Right. So after we go through all the results in this annotation, then we add that to the sample. So we say this field ground truth in the sample equals fo dot polylines, and we have to provide these polylines equals these polylines. Right. And again we have to save the sample in the data set. So we call sample dot save. So that's it. So if we run this, that works. And we can also take a look at the first sample in the data set. So now, as you can see, this the first sample, this is the file path, and for ground truth it has a polylines plural, and inside that it has polyline that has an ID, a label, and a list of points. Actually a nested list of points, a list of coordinates. So now let's visualize that. So we say session dot dataset equals this new DS. So if we run this now, we can see that each one of these images, they have a polyline or polygon around the bird or cat or dog. So let me change the color of this. So we can change the color, for example, oh no, sorry, I have to first select ground truth, and then here we can change the color, something that is more visible. Let's use this. Maybe this looks better, right? Yeah. So now you can see the polygon around the dog is shown in purple. Okay, so far we have seen different ways of creating a data set, whether reading directly from an image directory or starting from an empty data set and then adding samples to that one by one. And eventually we ended up with this data set that has polygons and right. Now, next thing, another capability of this FiftyOne is that we can filter the samples in almost any arbitrary way that we want. So let's say, for example, here these images, some of them have one object, but some of them have like multiple objects, right? Like this one has cat and dog, but this one only has cat and dog. Now let's filter this dataset and let's only extract the samples that have just one object. So to do that, first we need to import another module called view field, and usually they call it view field as F. And then this view field allows us to extract any field from the dataset from the samples in the dataset. So we say, since we named our labels ground truth, so in the ground truth field we have polylines, right? So this will basically give us the polylines for that for a particular sample, and we want to see how many polylines exist in that sample. So we say so we get the length of the polylines, so that means how many polylines exist in that sample. And now we want to filter the samples. So for filtering we can use ds.match, and with this view field that we provided here, this gives us the number of polylines, and we only want the ones that have just one, right? And the result of this is a view, right? So let's run this. So this will give us a view of 9 samples. So if we look at this here, we can see that there are 9 samples with just one label. So 1, 2, 3, 4, 5, 6, 7, 8, and 9. Now, how about the samples that have more than one? So let's copy this. For samples that have more than one object, we can say this length is greater than 1, right? So that this gives us a new view with only 4 samples. So let's assign that to a new variable and say session dot view equals this new view, right? So now we see this view that has only 4 samples. And we can also filter based on the labels, right? So if you want to do that, we say, let's say we want to extract all the samples that have cats and dogs, but we want to remove the label of birds. So to do that, we say ds.filter labels. So on the ground truth, then we want to look at the label. So note that ground truth has polylines, and then each polyline has polyline, a single polyline, and then that one has a label. But doing this, it will go directly to that label. So f of label dot, we specify is in, and the list of labels that we are interested in. So we only want cat and dog. We don't want the bird. So if you do this, let's also assign that to a view, and let's take a look at this view. Doing this will give us 10 samples. So let's visualize this view. Right. So now we can see we have 10 samples here that have cats and dogs. There is no sample that only has bird, but you may see this one. This one has the cat, but it also has the bird. But as you can see, the bird doesn't have any label, and that's fine. So we are ignoring the label for the bird. But if that sample has any of those other labels that we are interested in, it will still keep that sample for us. So yeah, that's it for this video. In this video we covered basically some of the essential functions of FiftyOne for dataset management. We looked at the FiftyOne dataset zoo, and we loaded one dataset from the zoo, and also looked at different ways of building a dataset from some local files with three different tasks in mind: classification, object detection, and instance segmentation. And also looked at some of the functions for filtering and sorting the labels as well. So I hope that you enjoyed this video, and thanks for watching.